In the world of computing devices, like laptops and smartphones, and increasingly, cars and scooters and just about everything else, there are toasters with computer innards these days. A patch is a piece of software that makes additions or changes to existing software within a particular device. So you might have a video game patch that downloads onto your Xbox, and that patch adds new functionality to a game. It corrects a bug, or it makes some other update to that software. And that update, these days at least, will generally be delivered via the internet, or in some cases over the air via wireless cellular signal or Wi-Fi, the latter of which isn't technically OTA, over the air, in the traditional sense, which initially referred to updates made via radio signal. But according to the way that we use that term today, a lot of our updates happen OTA. So these patches arrive seemingly by magic, keeping our devices updated to the most recent version. There are a few caveats and details that are important to mention here, so that this technology makes sense in the context of the broader topic that I want to discuss today. First, these updates almost always require that we approve the updates before they are fully implemented. This is a safety and rights-related thing, and it's part of what distinguishes the modern way of doing OTA updates from the previous radio-based implementation. Back in the day, centralized channel managers controlling the hub where all these different signals connected could send whatever updates they wanted to everyone connected to that hub, and those devices would update automatically, without human approval or intervention required. There were positive aspects to this way of doing things. All software on the network was always updated to the most recent version, for instance, which is beneficial for a whole lot of reasons. But it was also possible for a flawed patch, or even malicious piece of software, to be distributed in this way, which meant that if something bad happened to that central hub, it was also immediately and irrevocably implemented across that entire network, which was not ideal. Second, users do have vastly more power over how they use their devices and the software on those devices today. And that has resulted in an interesting conflict between the interests of the user and the interests of the hub controller, the company sending out these updates at times. The iOS operating system, for instance, which runs on iPhones and iPads, all of the mobile devices made by Apple, pretty much, pushes updates in a fairly pushy way, degrading newer software on older operating systems fairly quickly, so that those who do not stay up to date will not have the same functionality as those who do. Now, some of this is just a consequence of new things not working as well on older versions of OSs, but it's purported that some of these conflicts are a bit more intentional, meant to create frictions for those who do not update quickly enough to encourage more users to update faster. Consequently, as of the end of February 2019, over 80% of iOS device users have the most recent version of the operating system installed. This is a stark contrast to how things play out within the Android software ecosystem, where updates are delivered in the same way over the air, but the implementation of those updates are substantially staggered, with delays in installation due to the countless shapes and sizes of the devices upon which this operating system operates, and the many more permutations of and riffs on the OS, and limitations introduced by device makers and data providers who, at times, want to skin the OS to make their own apps and graphics and flourishes before they release them to their users, alongside security concerns, and in some cases, the removal of some fundamental Google-built apps and infrastructure that comes with Android, as is the case with Amazon's heavily altered version of the Google-built Android OS that is found in their Fire tablets and other devices. So although updates and patches are fairly standard across all software, from games to apps to operating systems, and although most of them are delivered in similar ways, the rate of installation of these changes is highly variable and influenced by all kinds of things, including user preference, and the desire, in some cases, to not have to set their phone aside for an hour while a massive file downloads, but also the operating schedule and principles of all the entities that exist between software maker and software consumer. And finally, it's worth recognizing that updates of this kind are not new. They've actually been around since the early days of computing. The term patch for an augmentation or update to a piece of software actually comes from the era of punch card computing, where programmers would tell computers what to do by punching holes in cards, which would then be fed into the machines. Those punches translated into ones and zeros. A patch, then, would be a literal patch to cover up some of those holes, or a replacement piece of cardstock or tape that would replace some holes with other holes, a means of updating the code when the code was written in a more tangible fashion. This is similar to the origin story behind the term bug for a failure or problem in a system that needs to be solved. An early pioneer of computing, Grace Hopper, encountered a problem with the Mark II and Mark III electric electromagnetic computers that she was working on at Harvard University in the mid-20th century. And the story goes that in 1946, she solved a problem that had caused no shortage of headaches. No one could figure out what was going on with these machines. And it turned out that a moth had gotten stuck in the guts of the machine. And she opened it up and found it, later taping the dead moth that had caused all the problems to the computer's logbook. And in that same book, she coined the term bug for a glitch or problem within such a system. There's evidence that other notable people may have used the term for similar issues previously, from Thomas Edison to Isaac Asimov, but Hopper's account is the most compelling and memorable to me. And it does seem to be the source of the most common use case for the term, related to seemingly unexplainable glitches within software today. What I'd like to talk about today is an issue related to bugs and patches, and one that is beginning to threaten other non-computer-related aspects of society, and which may, in the very near future, and which arguably already is, becoming a significant issue for governments, businesses, and even us individuals in increasingly uncomfortable ways. You are listening to Let's Know Things. I'm Colin Wright. Let's Know Things is an independent listener-supported show, so if you're enjoying the show and if you'd like to contribute in some way, at any level that makes sense for you, consider becoming a patron at patreon.com/letsknowthings. All right, let's get back to the show. There was an interesting piece cycling around the tech world recently. This piece was about a work of art called The Persistence of Chaos, and the medium was a consumer product, but not strictly found art. It was a laptop, a little Samsung notebook, off the shelf, but with one very important added component. It contained software viruses and malware that have thus far collectively caused more than $95 billion in economic damage. And that's just the damage that's been tracked and measured. The WannaCry ransom attack of May 2017 affected more than 200,000 computers in 150 countries, damaging, among many other entities, the National Health Services in the UK and Renault factories in France. It also contains Black Energy, which caused blackouts across the UK in 2015, along with My Doom, So Big, Dark Tequila, and the oldest piece of malware contained in this art project, I Love You, which was a piece of programming script that started spreading from the Philippines in May of 2000, and which sent copies of itself to everyone in the address book of its victims, while overwriting various types of files on their computers, including images, audio, and Microsoft Office files. But that first piece of malware that I mentioned, the WannaCry virus, is why I'm bringing up this particular art piece, which sold at auction for $1.3 million, by the way, and which was created by artist Gao Odong at the behest of the cybersecurity firm Deep Instinct. That WannaCry virus segues us toward the heart of today's topic. The article I'd like to start with today comes from the New York Times, and it's entitled, "In Baltimore and Beyond, a Stolen NSA Tool Wreaks Havoc." This piece was published on May 25th of 2019, and that's important because this is a story that will almost certainly be expounded upon by the time it's published, because this is something that's happening right now as I record this episode. So the specifics will almost certainly change within the next few days. There are a lot of people who hope that's the case, at least, and in a positive direction, to be more specific, as it could absolutely just as easily change in a more negative way. The focus of this article is a recent hack here in the United States, which has led to the capture of the online assets of the city of Baltimore, which has frozen city computers, shut down government email addresses and websites, hobbled their ability to assess and send out utility bills, and has kept them from sending out health-related and emergency alerts, among many other vital and arguably non-vital but still nice to have services and systems that have been messed with to varying degrees. This hack makes use of what's become known as ransomware, a piece of malware of malicious software that takes over someone's system, their logins and assets, their cloud backups, pretty much anything online or connected to the internet, and then holds those things hostage unless the owner of those logins and assets pays some kind of ransom, usually in Bitcoin or some other untraceable or difficult to track value-holding digital asset. These types of attacks have become dishearteningly common in recent years, in part because tools that allow more people to launch these sorts of attacks have become more widely available, and in part because more of our infrastructure has moved online. And that's true whether we're talking about individuals like you and me uploading our files to the cloud, our contacts to our phones and social media, and doing all of our banking online, or if we're talking about corporations and governments, with all of their employee files, payment records, distribution networks, office communications, unreleased products and plans, kept online for ease of use and sharing and distribution purposes, or because it's often just way cheaper to do so compared to other hard copy dependent methods. As described in this piece, though, what's especially frustrating about this and other similar recent cases of ransomware hijacking is that the tools being used are either based on or straight-up vanilla examples of a piece of malware tech developed by the NSA, the United States National Security Agency, almost certainly for primary use against the United States enemies, but which instead has been used many times in the past several years against targets based in the United States and targets within the US government itself. The shadow brokers, a group or individual that may be foreign or domestic, part of Russian cybersecurity or a US whistleblower, maybe a lone wolf hacker or a military wing from within or funded by a government entity somewhere. We don't really know at this point. But what we do know about this group or individual posing as a group is disconcerting enough for those who are involved in this space. First, we know that the shadow brokers, their moniker probably based on a character from a video game called Mass Effect, who deals in information, selling to whomever pays the highest price, has possession of a great many government-level hacking tools that were developed by a subgroup within the NSA called the Tailored Access Operations Unit, which, as their name implies, specializes in tapping networks and gaining access to things. This unit, the TAO, has been called the, quote, largest and arguably most important component of the NSA's Signals and Intelligence Directorate, end quote, which, if you recall what went down with Edward Snowden in 2013, when he blew the whistle on surveillance programs run by the US and other members of the Five Eyes Intelligence Alliance, which is made up of the US, Australia, Canada, New Zealand, and the UK, divulging that they were, along with the cooperation of a great many telecommunications companies and European governments, spying on essentially everyone all the time, leading to a huge paradigm shift in many people's perceptions of their governments and privacy and things of that nature. The TAO was a huge part of all that. This group figured out how to install taps on routers before rewrapping them and sending them to stores. They got surveillance equipment and internet infrastructure and cell phone towers. They coerced private companies to leave back doors in their software, so this wing of the government could use that software to spy and steal information. They, in essence, figured out how to watch everyone all of the time, and did so using a collection of tools and access that gave them a direct line to the networks that we use. So rather than hacking individual computers, most of the time they would just tap the network the computers they wanted to access were using and get what they wanted via that broader pathway instead. Somehow, the shadow brokers got their hands on some of these tools that allowed that kind of access, and they put those tools in the hands of essentially anyone who would pay for them. In September of 2016, they announced an online auction of exploits and other tools that the NSA utilized to break into overseas computer networks. And the group eventually, after making a not insignificant amount of money from that auction, presumably, they made those same tools public for anyone to pick up and use for free. There are publicly known theories about where these tools came from and how they ended up in the hands of the shadow brokers. Some involve whistleblowers and intentional theft via members of the NSA. Others involve carelessness or misunderstanding. One involves a high-up NSA employee who also happens to be a legit hoarder and thus collected confidential files alongside everything else, that information eventually getting into the hands of this group through his relatively easy-to-penetrate computer systems at home, rather than them having to find their way through the NSA's relatively high-end cybersecurity apparatus. Whatever the specifics, whatever the source, these tools, via the shadow brokers, found their way online. And the consequences were pretty staggering and almost immediate. Groups that were happy to commit illegal hacking were suddenly empowered to do so a lot more effectively than they would have been able to previously. To understand what this moment might have seemed like to folks in the cybersecurity world, imagine that criminals everywhere, folks who wanted to rob gas stations and banks, wanted to mug you on the street, all suddenly had access to machine guns, bazookas, landmines, and tanks. And these weapons of war, formerly primarily relegated to the battlefield, to conflicts between nation-states, were suddenly being used on ordinary citizens, and corporations, and local government entities. That's kind of what happened here, but in the digital world rather than the tangible one. Military-grade cyber weaponry was available to anyone who knew how to find it. And that meant highly sophisticated, incredibly powerful tools being used against unhardened or not hardened enough targets. And that these digital targets were digital was not as meaningfully different as you might at first suspect, due to the fact that we live in a world where the digital interweaves with the physical pretty much everywhere to some degree. Hence, the city of Baltimore, the government apparatus in a major American city, is currently, as I record this, being held hostage by, who knows, anonymous muggers using their bazookas and tanks to rob the whole city, Old West style. The larger story of this story is that this particular piece of ransomware, the one being used in Baltimore, called EternalBlue, is also at the core of the WannaCry attack, which we later found out was built by North Korea, which was able to paralyze the British NHS, parts of the German railway system, and a few 100,000 organizations around the world by unleashing it. Not a bad investment for a hermit state looking to cause damage to wealthier and more powerful perceived enemies. And Russia utilized the same core malware in their NotPetya attack, which hit Ukraine the hardest, but which also hit many of the corporations doing business in the country at that time, including FedEx and Merck, costing these two companies about $400 million and $670 million respectively. What really stings here is that EternalBlue, the source of so much damage, was predicated on a Windows exploit, a flaw in the Windows operating system that allowed the NSA to build code that gave them power over systems that used the version of Windows in which that flaw existed, that the NSA found and it didn't tell Microsoft about because they wanted to keep that crack in the system, that potential access hatch for themselves in case they needed it someday. After these attacks launched by other countries now using this exploit against the US and its interests, the NSA told Microsoft, which released a patch sealing up that crack in the majority of systems, but leaving it exposed to this day in many. Looping back around to what we were talking about in the intro, like Android users, Windows users do not always update their software immediately, for a variety of reasons, ranging from a history of glitchy updates to, in some cases, other software having been built atop that main software, and users not wanting to bork their specialized programs until an update for that other piece of software has been released. As a result, a lot of specialized systems, like ATM software, hospital software, and government software, most of which have very complex and expensive customizations built atop the core Windows software underneath, will often be years older than what most people have on their desktops and laptops. And if the folks running those networks, those devices, have not updated their older operating systems, out of negligence or out of caution, these types of exploits, even the ones that most people are patched and protected against, can still work their way in, taking over those systems and gaining surreptitious access to all kinds of vital, sensitive, and potentially very profitable information. From there, all they have to do is encrypt that information and all the means of accessing it, and send a little note to the owner of said systems, indicating that it will be unencrypted, that it will be made accessible again if they pay a certain amount of money into the Bitcoin account provided. And that's where we find ourselves currently. A world in which military-grade, nation-state powerful hacking software has been made available to pretty much everyone. And those tools are being used by anonymous forces large and small to cause substantial damage, and potentially make some unscrupulous people and organizations a lot of money because of the ransomware component of some of these attacks. So what can we take away from this situation? What's the broader context to this? First, we know that ransomware is becoming substantially more common day by day. It seems like every week there's another story about this software being used against large-scale and even somewhat shocking targets like hospitals or utility service companies, where the consequences of not paying off the criminals who use it becomes actual human lives. And that's not even taking into account the estimated 851 million other infections that were detected by researchers in 2018 alone, and their potential consequences. It's estimated that a new organization is hit by this kind of attack every 19 seconds in 2019, and that's currently predicted to increase to every 11 seconds in another 2 years. On average, it takes over a week to regain access to data once it has been encrypted, and 34% of businesses hit with malware take longer than a week to get their data and login capabilities back. And that's when they do get it back, which does not always happen, even when they pay off the ransomers. Second, part of why we're seeing this increase is because of the aforementioned military-grade hacking tools that have been made available to anyone who wants to use them. That's huge and scary, and not something that we can fix overnight. And that a lot of these tools are predicated on abusing the government's relationship with private tech companies makes it less likely that these companies will cooperate with the government in the future, which is a mixed blessing depending on how you look at it, as those agencies will likely have fewer tools to use against legitimately horrible entities that want to do legitimately horrible things, but it also leaves those government agencies with fewer ways to abuse their power over us, and would seem to put us at less risk, over time at least, because there will be overall fewer vulnerabilities that remain intentionally unfixed to be weaponized at some point. Third, it's become very clear that the threats we face will increase as our available tools increase in power. Or said another way, the bigger our guns, the more substantial the damage we can cause to each other. Some of our weapons of war will inevitably make it into the public sphere. Warfare does not stay in war zones anymore. So some parts of this story would seem to be a consequence of the concept of total war, being willing to destroy cities full of citizenry, not just soldiers on a battlefield, with the understanding that cities and citizens power a war machine from behind. This is a consequence of that thinking taken into the internet era. We are all potential resources for our side, and therefore worth crushing before we can benefit someone's enemies. We're all potential collateral. We are all also potential resources to be harvested, utilized, and looted by whomever, anyone with the right weapon that they can point at us to make us do what they want. Fourth, as we become more connected, everything is powered in some way by the internet, and this makes us more powerful but also more fragile. We could always, of course, disconnect, but choosing to run a business offline does not protect you entirely. It just protects you from some threats, and even those, not entirely. If you choose to do all of your bookkeeping on paper ledgers, your water and power could still go out as a result of a hack committed against your utility services. You could inconvenience yourself greatly and still not be able to avoid this particular threat vector. It's big enough and all-encompassing enough that it's almost impossible to avoid completely. And finally, a lot of the issues at play here seem to tie back to financial incentives, structural fragility based on complexity, and the simple fact that we cannot build bulletproof code or systems. This is a reality, and we may have to start building security and cybersecurity measures to account for that. As such, hardening the targets, making users and institutions more capable in this regard, more likely to catch problems before they become problems, might have to be part of the solution here. Asking folks on the consumer end to be responsible for their own security to some degree, rather than feeling that we are 100% protected by our government or corporate solutions providers, would not be a popular ask. But it may be one of the few ways we could truly up the complexity and cost of committing hacks of this kind on this scale for the folks who want to commit them. Rather than trying to blunt the weapons, we could try to make sure more people have thick hides when it comes to their overall digital presence. And those types of hides may be increasingly important, even vital, in a world where those weapons are just getting sharper and more abundant. If you are enjoying Let's Know Things, consider becoming a patron at patreon.com/letsknowthings. You can also help support the show by leaving a quick review wherever you get your podcasts, or sharing your favorite episode with your social network of choice, or with a friend who you think might enjoy it. A massive thanks to everyone who is already supporting the show in some way. You folks are the reason I'm able to commit the time that I do to this project each week, and I truly appreciate that. Thank you very much. The book that I'd like to recommend today is called The Age of Surveillance Capitalism, with the subtitle, The Fight for a Human Future at the New Frontier of Power. This is by the author Shoshana Zuboff. I was blown away by this book as soon as I started it. Almost immediately, it captured me. In part for the prose, it's incredibly well written, but also because it goes through and puts labels on a large number of concepts that I did not previously have labels for. And this author, she is somebody who's been researching the world of internet tracking and the advertising markets and always-on surveillance and pretty much what's happening in the world right now, especially post-early 2000s Silicon Valley and what's happening with companies like Facebook and Apple and Amazon and Google to various degrees, but also to a huge number of other tech companies in particular to various degrees, because it's been shown to be the golden goose, whatever industry you are technically in. She very eloquently expresses what is happening in this space and talks about how we got there and what it represents. So if you want to understand the context of these types of companies and the tech industry as a whole, specifically as it relates to us being tracked pretty much all the time for various purposes, this is essentially the book to read. Now, it is not without a perspective. She definitely does not feel great about the way this field is evolving, but I think that slant is integrated into the overall information in a very non-pushy way. And I would also argue that due to the extent and enormity of the way this field and this collection of entities have been growing, it would probably be a little bit dishonest to try to tell this story without any hint of bias, because it has become so all-encompassing, and because it has changed so many other things through a variety of knock-on effects. So if you'd like to understand what's going on in tech, and particularly where surveillance and tracking overlaps with capitalism, The Age of Surveillance Capitalism by Shoshana Zuboff is an excellent read that I highly recommend. You can find out more about me and my work at Colin.io. You can find my blog at exilelifestyle.com, and you can find the show notes for this episode and every episode of the podcast at letsknowthings.com. You can find out more about the tour that I'm currently on and get tickets if applicable at becomingtour.com, and you can find my advice column about life at somethoughtsoboutliving.com. Feel free to reach out and say howdy on your social network of choice. I'm Colin Wright on Facebook and at Colin is my name on Instagram and Twitter. Thank you so very much for listening. I'm Colin Wright, and I will talk to you again next week.